We're going to solve some equations now that have powers of the variable. Now, I misspoke when I wrote this. I wrote example, solve the nth root equations. Those are not nth root equations. They don't have an nth root in them. They have exponents. They have powers on the variable. So this should be written, example, solve the nth power equations. So we're going to solve nth power equations. We have two of these examples, part A and part B. Part A, it's a third power equation because the highest power on the variable is the third power, and part B is a second power equation because the highest power is the second power on the variable. Now, we will review the steps for solving an nth power equation where the n is some positive integer, as a positive whole number. And those are just three steps. Step 1, isolate the nth power expression. Step 2, take the nth root of both sides, using the rule that if you take the nth root of an odd number, you just take the nth root. But if you take the nth root of an even number, you're going to take positive or negative nth root. And then step 3, we're going to solve for the, or in other words, isolate the variable. So just keep in mind, if your answer turns out to be the even indexed root of a negative number, your answer is not going to be a real number. It's going to be an imaginary number. And that's what we remember from our past studies in algebra. So let's do part A first. Let's solve the third power equation. X to the third power minus 27 equals 0. Now this is a really easy one because it's missing any intermediate or any lower powers of x after the third power, so it's really easy to do this. First thing we're going to do is isolate the nth power. So isolate x to the third power by just adding 27 to both sides. Now we're ready to take the nth root, the third root of both sides. And then our answer would be the third root of 27. The third root of 27 is 3, and that's true because 3 to the third power is 3 times 3 times 3, 27. So that's our answer, and you'll notice since we took the odd indexed root of 27, we took the third root, we only consider the positive solution. Now let's look at the second example, part B. That's a second power on the variable. So step 1, we're going to isolate the second power term, which is actually the entire parenthesis, by moving 16 to the other side, negative 16 to the other side, by adding 16 to both sides. Now we're ready to get rid of the second power by taking the second root, in other words, the square root of both sides. And you'll notice this time we wrote plus or minus because when you take an even index root, in this case, the even index of our root is 2. It's a second root, also called a square root. Whenever you take the even index root, you have to consider both the positive and the negative root. So x minus 2 on the left is equal to plus or minus the positive or negative square root of 16. Now let's evaluate the square root of 16. That's equal to 4, so we have it equal to plus or minus the 4. And now let's isolate the x term for our final answer. X is equal to 2 plus or minus 4. Now, this is not simplified. Do not leave an answer which is so obviously begging for you to finish it in this form. Go ahead and separate these two solutions. Separate the 2 plus 4 and the 2 minus 4 and come up with an individual solution in both cases. So now we have our two solutions to this second degree problem. They are x equals 6 and x equals negative 3.